Okay, so this is EOCT Review Part 4, and let's get started. Alright, well, hopefully the first three are really easy, especially when you have the definitions right here in front of you. So, sine of an angle, opposite over hypotenuse. If this is the angle, opposite is 7, hypotenuse is 25. So, 7 over 25. Cosine adjacent over hypotenuse. So that would be 24 over 25. And tangent of an angle is opposite leg over adjacent leg. So if this is the angle, opposite is 7, adjacent leg is 24. So 7 over 24. So that's number 1. Okay, so it says the area of a square is 10 centimeters, 10 square centimeters. What is the product of the lengths of the diagonals? Okay, so let's break it down. First of all, you better draw a picture. When you see a blank area like this and they mention a shape like a square, first thing you better do is draw a square. Okay, so let's have a square. Alright, so there's my square. They said that the area is 10 square centimeters. Okay, the area is 10. Well, that's fine. We want to know something about the diagonals, which of course are the lines from vertex to vertex. We need to know more information. We'd love to know how long the sides of the square are. We don't know that yet. So since we don't know, let's just call it x. Since it's a square, both sides are the same, so I'll use the same variable, x and x. How do you find the area of a square? Base times height, length times width. So, given these variables, what would be an expression for the area of this square? Hopefully you said x squared. X times x, base times height, that would be x squared. So the area is 10, so in this case that means x squared must equal 10. Well, we can use this to find the length of the sides. So of course, to get x by itself, let's just take the square root of both sides. So that's going to give us x equals the square root of 10. Alright, fine. That tells me that the sides of this square, the sides are the square root of 10. So basically, so this is square root of 10, and this is square root of 10. Fine, but we're supposed to find the product of the diagonals. So let's get those diagonals in here. Well, here is a diagonal, for example. Okay, so that's one diagonal of this square. Obviously the other one would go like this. So they should be the same length. So let's find this and we'll know what both diagonals are. Well, since we're splitting up a square, how many degrees are we talking about here? Of course you know that this is a 45, 45, 90 triangle. So based on that, we should be able to use our special triangle rules in order to find the hypotenuse. Now you know that the hypotenuse is leg times radical 2. So like if this was just 10, it'd be 10, 10, and then 10 radical 2. The fact that this is a radical doesn't bother me. If this is radical 10, radical 10. This will be radical 10 radical 2. So the hypotenuse is the leg times radical 2. So radical 10 times radical 2. If you were to put this in your calculator, it's going to say, let's see, 2 radical 5. So that means this is 2 radical 5. Okay, now that is the diagonal. The diagonal is 2 radical 5. Now we're supposed to find the product of the diagonals. What does the word product mean? Well, hopefully you said that product means that we multiply. So, the product of the diagonals, well, each diagonal is 2 radical 5. So the product will be 2 radical 5 times 2 radical 5. If you put that into your calculator, you're going to get 20. So that is the product of the diagonals. Okay, let's take a look at problem number 3. A parallelogram has sides 10 and 20. The measure of the acute angles is 30 degrees. What's the area of the parallelogram? Again, we better draw a picture. So here's a parallelogram. The sides are 10 and 20. So let's say this is length 10, and this side right here would be length 20. Now we're supposed to find the area of this parallelogram. Well, to do that, it really helps to know the formula for the area of a parallelogram. The area of a parallelogram is given by, it's just base times height. Now, does that mean it's just going to be 20 times 10? Well, no, it doesn't. 20 is the base, but 10 is not the height. The height is a vertical line straight down perpendicular to this 20. So in other words, this is the height that would look like this. Whoops, I moved it. This is the height. Okay, of course, this is a 90-degree angle. So this is what we need to find in order to be able to do base times height. So what else do we know? 30 degrees. The acute angles of this parallelogram are 30 degrees. Well, that means this is 30 degrees. It's one of the acute angles. Well, in this right triangle, if this is 30 degrees, what's this up here? That's 60 degrees, of course. We have a 30, 60, 90 triangle. So again, we get to use our special triangle knowledge. Now this will be given to you, the little picture. Remember, this image will be given to you. So if you have a 30, 60, 90 triangle, start by looking at the short leg. Look at the relationship between the short leg, which is across from the 30, and the hypotenuse. The hypotenuse is always going to be double the short leg. The short leg will be half of the hypotenuse. Of course, if we know the short leg, the long leg will be the short leg times radical 3. Hold that in your mind for a minute. Okay, so like I just reminded you, the hypotenuse is always going to be double the short leg. So if the hypotenuse is 10, that means the short leg is going to be 5. That 5 is exactly what we were waiting for. So the area of this parallelogram is base times height. So that's just going to be 20 times 5, base times height. So that's 100. Okay, moving on to number 4. Alright, what is the area of a regular hexagon with sides that are 10 centimeters long? Well, what's a hexagon? This is a hexagon. It has 6 sides. So, in this hexagon, the fact that it's regular means that all of the sides are 10. Okay, so each one of these sides are 10. Now, in order to find the area, we don't have a formula for the area of a hexagon. So what I'd like to do is break this hexagon up into triangles. We know how to find the area of a triangle, so let's do that. Okay, so now I've divided this hexagon up into 6 triangles. So my strategy will be, let's find the area of one triangle. If I can find the area of one triangle, I can just multiply it by 6, and that will give me the area of this whole thing. Now, to be able to do that, we need some angles. We need some angles. So the part I'm going to say next is the key. How many degrees is it all the way around in a circle like this? If I go all the way around a circle, how many degrees is that? Of course, that's 360 degrees all the way around. Well, look how many triangles I have. If I take that 360 and divide it evenly between these triangles, how many degrees will I have at each one of these vertices? Well, it turns out 360 divided by 6 is 60. So that's why each one of these angles is going to be 60 degrees. Okay, every one of these is 60. That's important because that means I'm going to have 30, 60, 90 triangles. Not yet, but I'm going to. Now, if this angle is 60, can you figure out what these other angles are going to be down here? Think of it this way. How many degrees are there in a triangle? There are 180 degrees in a triangle. You might guess that both of these angles are going to be 60 as well, because it sort of looks like an equilateral triangle. And in this case, you'd be right, but let's go ahead and prove that. If this is 60, if you did 180 minus 60, what does that leave? That leaves 120. And I have these two angles and the symmetry, so I would have to share that 120 equally. So this would be 60 and 60. Okay? So keep that in mind. Each of these triangles has 3 60-degree angles. They're equilateral triangles. All the sides of these triangles are the same. We might need that later, so keep that in mind. Well, let's do this. Let's take one of these triangles and sort of move it off to the side so we can play with it. Okay? Let's take this triangle, for example. Let's just take it, move it off to the side. If we can figure out what the area of this triangle is, multiply it by 6, that will give us the area of the whole hexagon. Well, this is what we've got so far. We know that this is a 60-degree angle, for example. Now, what if we dropped an altitude down the middle? So we found the height. Of course, the area of a triangle is 1/2 base times height. So, I already know what the base of this triangle is. Okay? Remember that all of these triangles, we have each side is length 10. So this is like 10, 10, 10. And these are equilateral triangles. So every side of these triangles has length 10. So we already know that the base of this triangle is 10. All we need now is the height, and we're good. So let's go ahead and draw that in. So here is the height of the triangle. Okay, if I drop that height, of course I'm going to have a right triangle. If this is 60 degrees, that means this is 30 degrees. So I have a 30, 60, 90 triangle. Now guess what? If this length is 10, then we know that this length is going to be 5. And that is the short leg. Alright, so that's the short leg. So the height is the long leg. How do I get the long leg based on the short leg? Well, again, remember this. The long leg is the short leg times radical 3. So that's why if the short leg is 5, the long leg should be 5 radical 3. So now I've got my base of 10 and my height of 5 radical 3. So the area of this triangle is going to be 1/2 times 10 times 5 radical 3. You could just type that whole thing into your calculator. 1/2 times 10 times 5 radical 3. So you get 25 radical 3. Now, 25 radical 3 is the area of one triangle. We have 6 triangles making up this shape. So if I take this and I multiply it times 6, so if I do 6 times 25 radical 3, that should give me my final answer. Maybe I can just come back to here and just do times 6. Okay, well that's giving me the decimal. So if it were a decimal problem, this would be the answer, 259.8. But on the EOCT, this is likely to be an exact answer, a radical answer. So let's do this. Forget the radical 3. Let's just multiply the 25 times 6. So if I do 25 times 6, that gives me 150. So that means this will be 150 radical 3. Okay, so that is the answer to number 4. Number 5. A road ascends a hill at an angle of 4 degrees. Ascends just means it goes up. So a road goes up a hill at an angle of 4 degrees. That means this is a 4-degree angle. Oh yeah, draw a picture. Please, 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 please. Anytime they start describing a situation and they didn't give you a picture, you better draw a picture. So there's my 4 degrees. Of course, let's picture this as a right triangle. So for every 100 feet, how many feet does the road ascend? Again, this just means how many feet does it go up? Okay, so for every 100 feet of road, so let's examine this stretch of road that is 100 feet. We want to know how many feet the road ascends, how many feet it goes up. That means we are looking for X right here. We are looking for this length right here. Okay, because that's how high it goes up. Well, let's see. Looking at the 3 things we have this 4 degrees, and we have the 100, and we have the X. this is not a special triangle. It's not 45, it's not 60. So what do we have to do when it's not a special triangle? Can I do the Pythagorean theorem? No, not enough information. I only have one side. If I knew the bottom here, I could use the Pythagorean theorem, a squared plus b squared equals c squared. Not just with one side. What can I do? Those trig functions, tangent, sine, cosine. Think about that. Now, looking at the 4 degrees, looking at the x, looking at the 100. Which one of those trig functions am I going to use? These formulas will be given to you, so refer back to them. So we need to consider, are we talking about opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent? Looking at the 4 degrees, x is opposite and the 100 is the hypotenuse. So opposite and hypotenuse. Which function was that? That was the sine function. So we will say the sine of 4 degrees equals opposite over hypotenuse. All we have to do is solve this for x, and that will be the answer to the question. That'll be how many feet the road ascends, goes up. So how will I get x by itself? That's right, I'm going to multiply by 100 times 100 times 100. Alright, sure, I'm about to get a decimal right now, but remember, in many cases on the EOCT, which will be 100% multiple choice, a lot of times, instead of giving you decimal answers, they will give you answers in the form of an expression. So your answer might be 100 sine 4 degrees. They might just leave it like this. So watch out for that. Or they might say 100 times sine of 4 degrees. So look for things like this to be the answer to a question like this. Of course, you could put it in your calculator. In your calculator, it would look like this. And so your answer would be 6.9798. So we would round this to 7.0. And maybe that's what they would have on the EOCT. It'll probably be, sometimes it'll be a decimal, sometimes they'll have it as an expression. Just be ready for anything. So that's number 5. Okay, number 6. According to building codes, the maximum angle of ascent for staircase in a home is 42.5 degrees to get from the first floor to the second floor in a new home. Staircase will have a total vertical distance of 115.5 inches. What is the minimum horizontal distance to the nearest inch needed for the staircase? Sounds like we need a picture. Okay, here is a picture of the situation that was described. We are supposed to find the minimum horizontal distance to the nearest inch. So we're supposed to find this distance along the ground based on the 42.5 degrees and the height of 115. So again, this is not a special triangle, so we're going to have to use tangent, sine, or cosine to find this side of the triangle. Well, looking at the 42, 115.5, that is opposite. This x right here, the bottom, is adjacent. Opposite over adjacent. What function is that? That is the tangent function. So tangent of 42.5 degrees is opposite over adjacent. Okay, so we need to find x. How do we do that? Well, I could cross multiply, I guess, but I taught you guys a shortcut for when the variable is in the denominator like this. Do you remember the shortcut? I'm hoping you're thinking, yes, Mr. Burton, you taught us that we could reverse the position of these two. Okay, so the x is going to wind up here. The tangent of 42.5 will wind up in the denominator. So this will quickly become x equals 115.5 over the tangent of 42.5. Okay? They said the nearest tenth of an inch. No, they said the nearest inch, so that means we're going to be rounding. It's not just going to be an expression. So let's go ahead and put this in our calculator. In your calculator, it's going to look like this. So we get 126.04. So rounded to the nearest inch. That's just going to be 126 inches. And that is the answer to number 6. Alrighty then. The length of one diagonal of a rhombus is 12 centimeters. The measure of the angle opposite that diagonal is 60 degrees. What is the perimeter of the rhombus? Well, we got some vocabulary. We need to know what a rhombus is, what a diagonal is, what perimeter means. Let's draw a picture. Alright, who did not know I was going to say draw a picture? A rhombus is a shape that has 4 equal sides. A square is a special case of a rhombus, but in general it's going to be sort of a diamond shape. It doesn't have to be a square. So it'll be something like this. Okay, there's a rhombus, 4 equal sides. Boom! Now, they mentioned a 60-degree angle. So obviously that's not going to be these obtuse angles here. We're talking about the acute angles. So let's go ahead and draw that in. So 60-degree angles. There's one of them. They mentioned the diagonal. So here's a diagonal right here, going across like this. Just put that a little high, didn't I? Okay, so there is a diagonal. So I've got 60 degrees. I've got the diagonal that's across from it. That's opposite the 60 degrees. So that's what I have so far. They say the length of that one diagonal is 12 centimeters. Great. That means I've got 12 centimeters right here. So this is 12. Okay, that is fine and dandy. We're supposed to find the perimeter. What does the word perimeter mean? Well, the perimeter is what you get when you add up all the sides. So obviously we're going to need to know the length of these sides. I don't know any formulas for just an equilateral triangle like this. Yeah, so we know these are the same. So this is we know that this is an equilateral triangle. These two sides are the same. This is 60 degrees. These are going to be 60 degrees. It's equilateral. Okay, 60, 60, 60. Oh, you know what? I don't have to just answer my own question. Okay, this is an equilateral triangle. So maybe I shouldn't have rushed through that so quickly. One more time. I know this is an equilateral triangle because, let me go back in time. They gave me the 60. The total degrees in a triangle is 180. So if I did my 180 minus 60, that leaves 120. But I have to take that 120 and share it equally between the remaining two angles. I know it's equally because this is isosceles, because it's a rhombus, which has all the sides are the same. And if I share it equally, then I find that it's they're all 60. So if the angles are all 60, that means the sides are all the same also. Which means if this is 12 down here at the bottom, all the sides are 12. So this is 12, this is 12, this is 12, and this is 12. So as far as doing the perimeter, I'm going to just add up 12 4 times. 1, 2, 3, 4. 4 times 12 is 48. So that's why the perimeter is 48 centimeters. It's 4 12s. Boom! That's the easiest way to do that problem. Let's move on to number 8. Okay, angle J and K are complementary angles in a right triangle. The value of tangent J is 15 over 8. What is the value of sine J? Guess what I'm about to say right now. If you said draw a picture, you are correct. Next time I see you, I will give you a cookie. People, please draw me lots of pictures. I want to see pictures everywhere. When you do your homework, when you do the EOCT and you've got your scratch paper and I'm walking around the room. I want pictures. They are your friend. So they mentioned a right triangle, so let's draw ourselves a right triangle. Okay, great. There's a right triangle. What else we have going on in here? They mentioned angle J and K are complementary angles. Okay, so here's my 90 degrees. Okay, let's call this J and we'll call this K. It really didn't matter. Just pick one. Now, what else do they say, Jane? The value of the tangent of J is 15 over 8. Okay? That's the tangent of angle J. So tangent, what's the definition of tangent? What's that you say? Opposite over adjacent. Okay, that means 15 is opposite and 8 is adjacent. So looking at this picture, I'm talking about angle J. 15 would have to go here because it would have to be opposite, and the 8 would have to be adjacent. So the 8 would go here. Okay, now we're being asked for the value of the sine of angle J. Okay, we're supposed to find sine J. Sine J, of course, is opposite over hypotenuse. That's the sine function. So opposite is 15. We don't have the hypotenuse yet. How are we going to find it? Let's see. Let's call this H for hypotenuse. Let's do the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to do 8 squared plus 15 squared equals the hypotenuse squared. So that's going to be 64 plus 225 equals the hypotenuse squared. That's going to be 289 is equal to the hypotenuse squared. And then, of course, to get h by itself, we're going to take the square root of both sides. So the hypotenuse turns out to be 17. Okay. So, back to finding the sine of angle J. The sine is always going to be opposite over hypotenuse. So, looking at angle J, opposite is 15. And of course, the hypotenuse we just found was 17. So, the sine of angle J is 15 over 17. That's why the answer to this question is C. Do you see the value of drawing a picture? You would not just sit here and look at these words and try to choose. For most of these problems, it's all about drawing a picture. Please draw pictures. Okay. Oh, look, after all that preaching about drawing me a picture, this one already has a picture. So, aren't you lucky? Triangle RST is a right triangle. Okay, RST. So the big triangle here is a right triangle. We're supposed to find the area. What's the formula for the area of a triangle? This will be given to you. This is suddenly not working. Area equals 1/2 base times height. That's the formula for the area of a triangle. That will be given to you on the formula sheet. So we have the height right here. It's 6. All we need to know is the base. That's all we need. See this diagonal right here? That's just there to fake you out, man. Don't be fooled by it. We don't need it. We don't need it. Base, height. Ignore this diagonal line. So looking at the 70, x is opposite and 6 is adjacent. Okay, so you've got opposite and we've got adjacent. Sounds to me like this is a job for the tangent function. So we're going to say tangent of 70 is equal to opposite over adjacent. So x over 6. How am I going to get x by itself? I am going to multiply both sides by 6 like this. That way these 6's cancel each other out. Put this in your calculator. 6 tangent 70. We get 16.5. Okay, so you know what? We better keep more decimals than that since we're not actually quite done. So let's see, 16.485. Okay, that is the base. So when we go back to do 1/2 base times height, that's going to be 1/2 times 16.485 times height, which is 6. So 1/2 base times height. Just put all that into your calculator. Well, I'm getting 49.455. Okay, now I look over and I see 49.45. Boom! That's my answer.